Okay, so we're going to start off looking at this animation to see what kind of transformation this coordinate matrix will create. So we'll have to see where our image ends up. So the first thing that is done is just plotting each one of those points, the point -1, 2, -3, 2, -3, 5, -5, 5, -5, 2, and then remember drawing it, you go back to your original point. So make sure you're labeling those points with prime notation. And can you think about what transformation just occurred? Look at the picture and see if you can predict what just happened. So if we trace our original figure and we trace the axes, the y-axis and the x-axis, and put our pencil on the point that we want to keep still, which is the origin, notice what they did to the patty paper. They turned it. Remember, every time you do a quarter turn, that's 90 degrees, and so we only want one corner turn. Now, which direction did we go? This direction. Remember, when we go around in a coordinate plane, we don't say left and right and up and down. We say clockwise and counterclockwise. This was a counterclockwise turn. So, look at the angle between 2 points and using the point you're turning around as its vertex. So if I connect point F with the origin, which is where the point I was keeping still, that fixed point, and F prime, notice that they make a 90-degree angle together. So that was a 90-degree rotation in order to create that image point of F prime. So what happened was a 90-degree rotation counterclockwise around the origin. So whenever you have a rotation, there's a lot of information to include. You have to say a rotation, how many degrees, which direction, and around what point. So we had a rotation of 90 degrees counterclockwise around the point 0, 0, or the origin is what we call that. So can we think of a rule that will satisfy that transformation? So that's what we're looking at on our notes here. So let's look at our choices here. So notice the coordinates of F, that might help us, has 2, 1, and 2, 1 is being mapped to F prime, which has the coordinates -1, 2. Let's put one more just to be a little helpful. L is 2, 3, and it maps to L prime, which is -3, 2. Can you tell what's happening to the coordinates? First of all, do you see that the 2 in the X spot ended up in the Y spot? The Y of 1, it didn't only go into the X's spot, but it changed signs when it switched. Same with 2, 3. The X went to the Y, and the Y went to the X, but changed signs. So how would we write that as a generic rule? So we have a generic point XY. We know we want the X to end up in the Y spot. So this should just be an X. We want the Y to end up in the X's spot, but remember we want it to change its sign. So remember we have that negative sign in front, but we read it as the opposite of Y. So this is our ordered pair rule for a 90-degree rotation counterclockwise around the origin. XY is mapped to the opposite of Y, X. So if I had the point -3, 4, that I wanted to do a 90-degree rotation counterclockwise around the origin, it would map to, I would want the opposite of my Y, so that would be a -4, and then my X, -3. It would map to that point right there. Okay, we're going to apply a translation vector to a coordinate matrix. So remember, this is a vector inside angle brackets. So this represents my change in X, and this represents my change in Y. Since my change in X is positive, that means I can add that number to all of these X coordinates. So 2 plus 4 is 6, 2 plus 4 is 6, 5 plus 4 is 9, 5 plus 4 is 9, 2 plus 4 is 6, 2 plus 4 is 6. Those are my new X coordinates. Then the Y's, we're going down, this is up and down movement, down 6. So I need to subtract 6 from each one of these Y's. 1 minus 6 is negative 5, 3 minus 6 is negative 3, 3 minus 6 is negative 3, 5 minus 6 is negative 1, 5 minus 6 is negative 1, and 3 minus 6 is negative 3. So we could write our coordinate matrix for that new image. It is 6, negative 5, 6, negative 3, 9, negative 3, 9, negative 1, 6, negative 1, 6, negative 3. The other thing that we could have done is plotted our original figure by plotting the point 2, 1, 2, 3, 5, 3, 5, 5, 2, 5, and remember it closes up at 2, 3. So it's the flag again. You're going from here to here to here to here to here and closing it back up. Okay, then we could have just moved each one of these points to the right 4 and down 6. So remember, this is my F point going to the right 4, 1, 2, 3, 4, down 6, 1, 2, 3, 4, 5, 6. Do you see that F prime is located at the point 6, negative 5, and that's where we had it as well. So then our L point at 2, 3, if I take that one 4 to the right and 6 down, it ends up right here at 6, negative 3, which is where we had it as well. And then A was at 5, 3, so go to the right 4, 1, 2, 3, 4, down 6, 1, 2, 3, 4, 5, 6. Here's A prime at 9, negative 3, which is where we had it. And then the same with G, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Here's G prime at 9, negative 1, which is where we had it. And then finally our S, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 at 6, negative 1, and that's where we had it. So we can connect to join our flag together, F to L to A prime to G prime to S prime to L prime. And there's the completed flag. All right, that is the end of your notes, but I want to do a little review for you. So if you'll turn to the back page where it's nice and blank, we are going to just review these different ordered pair rules. You need to really study these for your next test. So you can write these down and study these. The first one is the translation with the vector HK. Remember that ordered pair rule? All of them begin with X, Y, and an arrow. This translation would take my X and add the value of H. Oops, didn't mean to put that parentheses. Let's do a comma. And then my Y value, sorry, really messing that up, and adding my K to it. So that is the ordered pair rule for the translation with the vector HK. I'll write it better underneath. X plus H, comma, Y plus K. So you take your original X and do the horizontal change to that, and your original Y and do the vertical change to that. The next one is the reflection across the x-axis. So remember, every ordered pair rule will begin with the generic point xy and map it to a new point, and you have to describe what you're doing to the x and y. When you reflect across the x, you're doing up and down movement, and that changes the sign on y. So x stays the same, y changes signs. So x opposite y. The next one is reflection across the y-axis. Remember, this is now left to right movement. That is a change on the x. So xy is mapped to opposite xy. The next one is another reflection. This time it's across the line y equals x. So remember, that reflection takes a point xy and switches the coordinates. So it's mapped to yx. The next one is a reflection across the x-axis and then followed by the reflection across the y-axis. So that means xy is being mapped to reflecting across the x, changes the sign on y. Reflecting across the y changes the sign on x, so both the x and the y end up having a sign change. Opposite x, opposite y. The next one is a rotation 180 degrees around the origin, which is the point 0, 0. That takes a point xy, and it simply changes the sign on x and y as well. So remember, these are equivalent to one another. A double reflection across the axes is the same thing as a 180 degree rotation around the origin. Same result. The next one is a rotation 90 degrees counterclockwise. That's the one that we just looked at. So that takes a point x, y. It switches their places, but changes the sign on y. So that maps to opposite y, x. The final one is a rotation 90 degrees clockwise, and both of these are around the point 0, 0. I didn't write that, but that maps a point x, y. It also switches the x and y, but this time the x changes the sign. So y, opposite x. So really make sure that you have all of these rules memorized. So if we give you a point, you could perform every one of these transformations to it. So let's just take a point and let's practice that. So if I give you the point -5, 1, we should be able to do each one of these transformations to it. So if I give you a translation vector of 2, -3, that means I'm moving to the right 2, so I would add 2 to the -5. -5 plus 2 is -3. And this is the up and down change. Negative means we're going down 3, so I need to subtract 3 from the 1, and that gives me the y-coordinate of -2. If I'm reflecting across the x-axis, I'm changing the sign on the y-coordinate, so the x-coordinate is going to stay -5. The y is going to change signs and become -1. If we're reflecting across the y-axis, we change the sign on x. So my x was -5, so it is now +5, but my y doesn't change, so it's still a +1. If I want to take -5, 1 and reflect it across y equals x, I just switch the places of the x and y, so that would become the point 1, -5. If I reflect across the x and then the y-axis, remember it changes the sign on y and then changes the sign on x, so they both change signs, so that would become the point +5, -1. The rotation 180 degrees around the origin is the same exact result as that double reflection, so it is also 5, -1. Rotation 90 degrees counterclockwise switches the x and y and changes the sign on y. So my y was 1, so my x will be -1, the opposite of that y. My x becomes the new y, -5. If I rotate clockwise, then I'm going to switch the coordinates but change the sign on the x. So my new x was my old y, so it's just 1. But my new y is the opposite of x. X was -5, so the opposite of that is +5. So really study these transformations.